This video is on solving systems of inequalities given a graph. When you graph an equation, the solutions are all the points on the line, as we have studied in class. When graphing an inequality, the solution are all the points above or below the line and might even include the line itself or not, depending on the inequality symbol. In this case, you can see the equation y equals x plus 4 is shown on this line. The solutions, the points that work in this equation, are on this line. Every point on the line is a solution to the equation. Well, for the inequality y is less than x plus 4, the solutions are everywhere below the line. Below, because we have a less than, that dashed line tells us that it does not include the points on the line. If it wanted to include the points on the line, there would be an equal to underneath the less than symbol. And every point in this shaded area, if plugged in for the x and y value here, would work, would make a true statement. So to graph a linear inequality, which we're mostly going to focus on tomorrow, you have to follow 3 steps. First, you have to rearrange the equation so the y is on the left and everything else is on the right. Then we're going to plot the y equals line. Make it a solid line for less than or equal to or greater than or equal to, and a dashed line if it's just less than or greater than. And then we're going to shade either above the line for greater than or equal to, or below the line for less than or equal to. So an example here is the inequality y is less than or equal to 2x minus 1. The inequality already has the y on the left and everything else on the right. So basically slope-intercept form. So there's no need for us to change anything around, but you should always check for that first. Next, we're going to plot the y equals version of this inequality, and we're plotting it as a solid line because the less than or equal to includes that equal to symbol, which means we're including the line itself. We've decided to shade the area below this line because y is less than or equal to. And if you check any point, if you're not sure if you've picked the right region to shade, pick any point, for instance the point 4, 0, and if you plug that in for the x and the y, you will get a true statement. In this case, 0 is less than or equal to 8 minus 1, which is 7, and 0 is less than 7. Since this point in the shaded area makes a true statement, you can assume that every point on that side of the line will also make a true statement if you've graphed the line correctly. We'll practice this in class, but first we're going to focus just on partially drawn graphs. The boundary lines, which is the line itself, is already drawn for each of these 3 inequalities. I want you to pause the video and just shade the correct side of the inequality. Remember, you're shading above for greater than or equal to, below for less than or equal to. And if you're not sure if you're picking the right side of the line, pick a point, an easy one, and test it for x and y in the equation, in the inequality. Make sure you get a true statement. Pause the video now and try these. So how'd you do? For the first inequality, we have a greater than symbol. And so a common mistake is just to go sort of to the right, but greater than is above the line. And so if you sort of hold your hand up at the same slant of the line, think about where it would be above your hand. And it would be this part of the graph shown in red. For graph number 2, we have less than or equal to, so we have this solid line here, and less than is below the graph. In the same way that you can pick a point on the side you think it is, sometimes the point 0, 0 is so easy to plug in that you might check yourself by plugging that point in. And in this case, you want to make sure it doesn't work. If you've shaded the correct side of this line, 0, 0 should not be a solution to the inequality. And if you plug in 0 less than or equal to, and we get 0 minus 9 is negative 9. Well, 0 is not less than negative 9, which makes sense. We don't want 0, 0 to be a solution here because we have not shaded that side of the line. The last one is a vertical line, and this is sometimes confusing for students. Again, you can plug in any point. Notice there's just an x in the equation, and so any x value on this side of the line drawn will do. 0 is on this side. Is 0 greater than 3? Well, no, that's not true. So don't shade this side of the line that you drew, shade the other side. Let's take a look at this one. We're asked, which inequality graph shown? And you're given a multiple choice question here. One of the skills I want you to remember is using slope and y-intercept to check the line already drawn on a graph or to draw it yourself, which you'll be working on tomorrow. Today we're going to focus on recognizing the right inequality for the graph. And so if we look at this graph, first of all, we see shading above. And so what kind of inequality symbol should our inequality show? I hope you said a greater than or a greater than or equal to. But now I want you to look at something else. I have a dashed line drawn. So should I be looking at something that includes the line or doesn't include the line? Is equal to a point on the line or is not equal to a point on the line? I hope that you remember from a few minutes ago that we need, in that case, no equal to underneath because the dashed line means we are not including the points on the line. And so if we know we want strictly greater than here, we can rule out several of our choices. In this case, that won't work. That won't work. We're looking at the symbols. This won't work, and it appears that our answer has to be D. Now, you won't always have everything get ruled out, so we do need to make sure that we're looking at the correct line. What is our slope in this case, and what is our y-intercept? In this case, slope is 1/3, and the y-intercept is 2. So I need to make sure that my line has that slope and y-intercept. I can see a y-intercept of 2, so that's great. And I have to check slope. This slope says that from any point on the line, I need to go up 1 and right 3. So let's try it. If I start here and I go up, went too far, up 1 and right 3, I do land back on the line, which is exactly what I want to happen. So D is the correct choice. A system of inequalities is simply more than one inequality, just like a system of equations was more than one equation. The solution to a system is just the overlapped shading. And so here you see this inequality graphed and shaded properly, and you see this inequality in red, graphed and shaded properly. Well, the solution to the system of inequalities, the two inequalities together, will be the overlapped shading. This is not working out, my selection tool. So I can actually grab this graph and overlay it on top of the other one, which of course on paper is more difficult to do. But you can see where the red and the blue overlapped. And it is this region right here. And this region of the graph is the solution to this system of two inequalities. And so when you're asked to solve a system, you draw both of the graphs on the same coordinate plane, and then you would just darken in or maybe erase the parts that don't overlap and keep the part that does overlap. That is your solution. Let's practice writing the system of inequalities. Notice that in this case, just the overlap is left shaded in these graphs. I want you to pause the video and use slope and y-intercept to write the inequality for this line and for this line. Take a few minutes and do that now. So in red, you'll see my final answer. I went through a process, and you should do the same. For line 1, which I numbered as this line just for convenience, I identified my slope, m, and my y-intercept. And so I made a dot there so that I could use the y-intercept as one of my points to count slope. I found another point that looks like it's on the grid, and I counted. Something that you may not have noticed here was the scale was 2. Each line counted by 2's. And so if you did that, you would have gotten a different answer. You do need to pay attention to the scale being used. I noticed a solid line, and the shading was below this line. And so that told me to use less than or equal to, and there is my slope-intercept form of my inequality. I did the same thing for line 2, and so this, in red, is the system of equations shown on this graph. I want you, when the video is over, to go ahead and do the next one on your own paper so that you can check it in class. In summary, you're going to be writing the inequality for each line and shaded region separately by counting slope and locating the y-intercept for the m and the b in your inequality. Then you're going to decide greater than if shading is above or less than if shading is below. Also, decide whether to use the or equal to line under the inequality symbol. A dashed line, don't use it. A solid line, you should have the or equal to line under the inequality. Remember, the solution to a system of inequalities is the overlapped shading.